Hello, welcome to the course on microwave and antennas. In this lecture, we will learn about transmission lines. Before we get deeper into understanding the equations, let us start with basics. What is a transmission line? I'm sure you have seen this image before. This is an overhead line used to supply power to our homes, offices, college, hospitals, industry, and so on. These lines carry very high power, but remember, they carry low frequency AC signals. We know that this AC supply frequency in India is 50 Hz, which means it does not fall under microwave frequencies. Remember that microwave frequencies have to be really high compared to 50 Hz, like say 100 megahertz or 1 gigahertz or something in that range. So, to clarify, this course is not about these overhead power lines. Have you seen any of these objects? This is a simple TV cable connecting TV to the antenna. This is a simple USB cable connecting PC to your mobile phone. All these are transmission lines since the frequency of operation is like hundreds of megahertz. Now look at this picture. This is a PCB or a printed circuit board. So if you look closely, can you see these lines here? These are wires on the PCB to connect two devices. This is similar to say a USB where you connect between say your phone and your laptop. But in case of PCB, because the hardware is so small, the wire is small and it looks like a line. This is the transmission line and this is what we will be focusing in this course. So we now know how a transmission line looks like. Then the question is, what is a transmission line? Let us learn about this in the next slide. So, if the transmission line is a simple wire or cable, like how we saw in the previous slide, then what is so special about it that we need to study? We have seen all these electrical wires in our homes. For example, this is, say, a wire to connect from a plug to a bulb, and this is used for the purposes of lighting. Technically, we cannot call that wire as a transmission line. So then the definition of transmission line is based on the frequency of operation. Since we are talking about line which has some length, let us say the definition is based on the wavelength of the operation instead of frequency of operation. If wavelength is very large compared to the length of the wire or line connecting to devices, then transmission line theory is not applicable and we have to apply the circuit theory. Now, if the wavelength is comparable to the length of wire or line connecting to devices, then transmission line theory is applicable. Let us see this with a picture. Now, if you see here, this is a low frequency signal and this is a high frequency signal, and this is the length of the transmission line or the wire. If you notice here, when frequency is high, there are many cycles of the signal which cover the transmission line or the length of the wire, compared to low frequency where the wavelength is so long that the length of the wire is negligible compared to the wavelength of the signal. So why transmission line theory? Remember now that the transmission line length covers many cycles or waves. This means the voltages and currents are changing rapidly over the length of line. Unlike the simple DC wires where we can safely assume that voltage and current is almost same at different points on line, except say drop due to the resistance, here the voltages and currents are varying rapidly at different points on the line. This means the voltage and currents are varying with position on the line. So if you pick 2 points on the line, say voltage at point A on the line and voltage at point B on the line, the voltages can be represented as VA and VB, and VA need not be equal to VB, unlike a DC circuit or a low frequency circuit where VA is almost equal to VB